Alrighty, so I solved problem 4.2.21. Sorry about this, but I accidentally got the size wrong and the margins wrong, so I'm going to be moving the camera. But this problem, a particular farmer has 2,600 feet of fencing available to enclose a rectangular area bordering a river. If no fencing is required along the river, find out the dimensions of the fence that will maximize the area. What is the maximum area? So let's go ahead and write down, like I've done here, the things that we need to solve for. That way we know when we're done trying to figure out this problem, we know what we're answering and we make sure we get those answered. So let's draw a picture. We have the river right here, and we've got this fence, and we want to maximize the area of this fenced in area here. So area, first off, is we'll make this side x, this side y, which makes this one also x, because these two will be the same because it's a rectangle. So area equals x times y. Now the perimeter of this fence is 2,600. So to get that outside line on the fence, we need to add x plus y. So that's the same thing as 2x plus y equals 2,600 feet. Now, what we need to do is we need to get y by itself. So let's subtract 2x from both sides. We get y equals negative 2x plus 2,600. Okay, so here's one equation that we have. Here's another equation that we have, though, and if we combine them, it'll make a quadratic equation, and then we can start finding the maximum area and such. So let's combine these. Anytime we see a y in this equation, let's substitute this. So over here we get a equals, a being area, equals x times negative 2x plus 2,600 feet. Now we'll distribute. So negative 2x squared plus 2,600 feet, 2,600x. Let me rewrite that. Negative 2x squared, when x is multiplied by negative 2x squared, plus x being multiplied by 2,600, so 2,600x. We'll leave the feet off for now. So this is what we have is equal to a. Now we can find the maximum area by taking x, and we will use our little maximum formula for the vertex, and that's negative b over 2a. So b is this number, b this number, a is this number. So let's plug it into this formula here. We get negative 2,600 over 2 times negative 2. Now 2 times 2 is 4, and this is negative 2,600. The negatives will actually cancel each other out here, and when we divide this all out, we get a number 650. So this is, if you want to look at it in terms of a graph, we have this graph here, and it looks something like this, and our vertex is right here. The x portion of that is 650, so that is this way, and then later we'll actually need to find this one as well, but that's just kind of a way you can look at that. So this 650 now can be plugged into both of these x's here. 650, 650. Now these actually are the answer to this right here. So for our width, we have 650 feet. Now the length is what we need to find, and when we add these together, we get 1,300. Now, if we take 2,000 here, 650 plus 650 equals 1,300. So now if we take 2,600, the length of fence we have all together, and subtract these from it, subtract 1,300, 26 divided by 2 is actually 13. So this is actually 1/2 of this. So this is 1,300. So y is 1,300. Y being the length of 1,300 feet. Now, to find the area, we could do multiple things. We'll do it the quickest and easiest way, I think, and that would be to plug it back into this formula here. The area is x times y. X times y. So 650 times 1,300 right there. And when we do this, let me get my calculator real quick. We take 650, I don't know if you can see that, there we go, 650 times 1,300, we get 845,000. So let's write that down. 845,000. So 845,000 feet squared is our maximum area for this pasture or whatever this farmer's wanting to do. So there you go.